Welcome to solving basic differential equations. So recall from calculus, if capital F prime of x is equal to lowercase f of x, then we have that capital F of x is an antiderivative of lowercase f of x. So if we want to find solutions to a differential equation, to find solutions to the differential equation of the form y prime equals lowercase f of x, then we just have to integrate. And so we get that y is simply equal to the integral of lowercase f of x. Dx should give us solutions. And this is just the indefinite integral. We will have our plus c, which is good. We should have multiple solutions to most differential equations. So for our first example, let's find all solutions to the differential equation y prime equals 3x squared minus 2x. So what we get then is y is equal to the integral of 3x squared minus 2x dx. Taking that integral, we use our power rule. We would have 3x cubed divided by our new power 3 minus 2x squared divided by our new power 2, right? Raise the power by 1, divide by the new power, and then we'd have plus c. So we get our solutions are y equals x cubed minus x squared plus c. Next up, we want to find all solutions to the differential equation y prime equals x squared times cosine of x. So what we have then is y is equal to the integral of x squared times cosine of x dx. I will very quickly run through what I call rapid repeated integration by parts in this problem. If you need a quick review of various integration techniques, I will have a couple videos that you can review, which will be differential equations review of integration techniques. But for going from here, I'm going to do rapid repeated integration by parts. So I'm going to separate this x squared cosine x dx into a u and dv. The one that's derivative ultimately sort of goes down as what we'll take as our u. So here we'll have x squared and then cosine x dx will be our dv. As we work our way down, we are going to take derivatives for the u, and we're going to integrate on the dv column. So here we're going to take derivative. And here we're going to integrate. So derivative of x squared is 2x. The integral of cosine x is sine of x. Derivative of 2x is 2. Integral of sine is negative cosine x. And then I just keep going until I hit 0 if we have that luxury. Derivative of 2 is 0. Integral of negative cosine x is negative sine of x. I need to give myself a little more space here. Well, now the trick is you multiply sort of on the diagonal. And we'll take the positive multiplication, then the negative, and then the positive. So what we wind up getting then is y is equal to positive x squared times sine of x. And then we will subtract off 2x times negative cosine x. Then we will add on a 2 times negative sine x. And then don't forget, anytime we're integrating, we have our plus c. So again, this becomes y equals x squared sine x plus 2x cosine of x minus 2 sine x plus c. Again, if you need a quick review of various integration techniques, I will have a differential equations review of integration techniques video or two that you can watch. All right, one more, we want to find the solutions to y triple prime is equal to cosine of 5x. So first thing we're going to do is we're going to find the integral of that should give us the second derivative. So the second derivative of y, or y double prime, will be the integral of cosine of 5x dx. Taking this integral, you could do u substitution, setting u equal to 5x if you like, or if you just remember your rules, we wind up with 1/5 sine of 5x, and I'm going to say plus c1. The reason why I have a plus c1 is because each time we integrate, we're going to have to add in another constant. This way we can sort of distinguish between them. Next up, we'll have the first derivative is equal to the integral of the second derivative. And so we have y prime is equal to the integral of 1/5 sine of 5x plus c1 dx. So we wind up getting that y prime is equal to integral of sine is negative cosine. Again, use substitution, we're going to have to divide by another 5. So we'll have negative 1/25 cosine of 5x plus c1, integrating a constant, you just have plus c1 times x. And now we will have a plus c2. From here, we can go ahead and find y. So y will be the integral of y prime dx, or y is equal to the integral of negative 1/25 times cosine of 5x plus c1x plus c2 dx. So this becomes integral of cosine is sine. So we will again have our dividing by 5 from our u substitution. So we have negative 1/125 sine of 5x. Then we would have plus c1 x squared divided by 2 plus c2x. And here's our final constant plus c3. For the sake of simplifying things, c1/2 is also just a constant. Since c1 can be any constant, we can kind of absorb that divided by 2 into our c1. So let's just go ahead and set c equal to c1/2. Then we wind up getting that y is equal to negative 1/125 sine of 5x plus cx squared plus c2x plus c3. So again, anytime we integrate, you're going to introduce another constant. So theoretically, if we have a first order differential equation, we should just be introducing one constant. Second order, we should introduce two constants since we have to integrate twice. Third order, we introduce three constants. If we kept going, whatever the order of the equation, we should then have that many constants involved.